In this video, we're going to be covering trigonometric functions. So the first thing we're going to do is actually define the unit circle, and then we will define the 6 trigonometric functions based on that. So our unit circle is the circle centered at the origin with radius 1. The equation for this is x squared plus y squared is equal to 1. This coordinate is 1, 0. Up here we get 0, 1. Negative 1, 0 on the left, and 0, negative 1 down at the bottom. And again, that's the unit circle, which is a circle centered at the origin of radius 1. So what are the 6 trigonometric functions? We're going to start by defining sine of t. So let's suppose we have an angle t. Your book may also use theta quite a bit, so I'll interchange between t and theta as well. So we have sine of t here, and sine of t is equal to y. We define that to be y. First off, what is t? T is an angle. And what is that? What is an angle? Well, that can be any real number. All right. And what is y? Y is the y-coordinate on the unit circle where the angle t meets the unit circle. What do I mean by that? Well, let's suppose that we have some angle t here, and recall that when we draw this, we place this in standard position, which means that our initial side is along the positive x-axis, and we have some terminal side. So t is the angle between those, and sine of t is the y value here. So there is some x, y that our angle intersects the circle at, and sine of t we define to be the y value here. Okay, well, let's move on. If we have a value for the y value, if we have a trigonometric function for the y value, we also need one for an x value. So we get cosine of t is x. This is how we define our cosine. We also define 4 others, and those are secant of t, which is 1 over cosine, which is 1 over x. We also have cosecant of t, which is 1 over sine of t, which is 1 over y. And then we have tangent of t and cotangent of t. Tangent of t is y over x, and cotangent of t is x over y. We have another way that we can think about this that might be a little simpler to remember, so I'm going to write that down now. We may also draw the picture, a triangle here. I'm going to go back up to the first picture just to show you where that triangle is. We go back to this picture. Notice that I can draw a line here, and we have a triangle. our x value is down along the bottom, the y value is here, and we have some hypotenuse there. So, if we define some angle here, which maybe now I'll call theta, doesn't matter whether we call it theta or t. This side is the adjacent side, i.e. it is adjacent to this angle. This is the opposite side. And we have our hypotenuse here. Notice also that the opposite side here, when we have the unit circle, when we're on the unit circle, the hypotenuse is 1, the opposite side is our y value, and the adjacent side is our x value. That's, of course, when we're on the unit circle. But how does this relate to what we just did? Well, then, what is sine of t? Sine of t is then the opposite side divided by the hypotenuse. Cosine of t, I'll use theta, sorry. Cosine of theta. And sine of theta. Cosine of theta is adjacent over hypotenuse. Notice that this would be x over 1, which is just x in the unit circle. So this is the same as what we had just written. Similarly, secant of theta is 1 over cosine, which means we switch these. This is the hypotenuse over the adjacent side. We have cosecant of theta, which is 1 over sine. 1 over sine is 1 over opposite over hypotenuse, so that becomes the hypotenuse over the opposite side. And finally, tangent of t is opposite over adjacent, and cotangent, oh, I did it again, theta. Cotangent of theta is equal to the adjacent side over the opposite side. And that's how we define our 6 trigonometric functions. Now let's get some practice with that. So example 1. Will be to find the values of the 6 trig functions of t when, and we're going to say that t is this angle here, where our point is p of negative 5/13, comma negative 12/13. So the x value is negative 5/13 and the y value is negative 12/13. What I'd like to remind you is there is a triangle here. Let's see what that triangle is. That triangle is right there. It is a right triangle. The x value is negative 5/13. The y value is negative 12/13. So let's redraw that triangle over here. This is the same triangle, I just rotated it back around. So this here is 12/13, or really it was the negative 12/13. This side is 5/13, and we have the hypotenuse. Well, we have a right triangle here. How do we find the hypotenuse? Well, we use the Pythagorean Theorem. So x squared, 5/13 squared, plus y squared, which is 12/13 squared. What is that equal to? This is 25 over 169 plus 144 over 169 is equal to 169 over 169. What is that? Well, that's of course 1, which tells us this hypotenuse is 1. So in fact, this point is on the unit circle. So this circle I drew happens to be the unit circle. So what can we do with that information then? Well, what is cosine of t? That is again adjacent over the hypotenuse. What was the adjacent side? The adjacent side was 5/13, right? This is the same angle as this angle here. So the adjacent side is 5/13, except it was actually negative 5/13, right? So we get negative 5/13. And of course the hypotenuse is 1, so it's negative 5/13 over 1. I just didn't write that. If we follow along the same logic here, sine of t is negative 12/13. And now we can use the previous thing that we wrote down, which you can go back and look at if you need, to fill out the other 4. All right, so we did cosine and sine here. The opposite of cosine is secant. Secant is hypotenuse over adjacent, which is also 1 over cosine, if we remember. Well, what was cosine? Cosine's negative 5/13. This is negative 13/5. Similarly, cosecant of t is 1 over sine, so this is negative 13 over 12. Tangent of t is opposite over adjacent. Opposite side is negative 12/13. Adjacent side is negative 5/13. If we finish out this calculation, we end up with 12/5, positive 12/5. Reminder that if you're dividing fractions, you flip the second and multiply. So go ahead and do that on your own to confirm this is 12/5. Cotangent of t is adjacent over opposite, which is also 1 over tangent of t. So 1 over tangent of t is 5/12. And we have found all 6, cosine, sine, secant, cosecant, tangent, and cotangent. We found all 6 trig functions based on this angle t that we drew down at the beginning. Great. Just a couple more things I will say in this video. The first thing is the cosine and secant functions are even. What does that mean? Again, this means that cosine of negative t is equal to cosine of positive t, right? An even function, a function is even if f of negative x is equal to positive f of x. So cosine of negative t is equal to cosine of positive t. And of course, secant of negative t is equal to secant of positive t. Sine, cosecant, tangent, and cotangent are all odd functions. You might remember what those mean at this point, but just as a reminder, this is sine of negative t is equal to negative sine of t. Cosecant of negative t is equal to negative cosecant of t. of positive t. And then, of course, tangent of negative t is equal to negative tangent of t. And cotangent of negative t is equal to negative cotangent of t. Okay. So if we use a quick example, using that, notice that if tangent of 11 pi over 6 is equal to negative root 3 over 3, then what is tangent of negative 11 pi over 6? What is that equal to? Well, tangent of negative 11 pi over 6 must be negative of the tangent of the positive angle here. But we were just told what that was, so this is negative of negative root 3 over 3. Or in other words, this is positive root 3 over 3. And that's where we'll end this video.